Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. When we think of the world's most advanced data storage, our minds immediately jump to massive server farms, silicon chips, or perhaps the emerging field of DNA storage. But deep beneath the frozen plateaus of Antarctica and the massive ice sheets of Greenland, nature has been running its own archival system for nearly 1 million years. This is the cryogenic Cipher, a vast, subterranean library of gas and dust trapped in tiny, pressurized bubbles. These bubbles aren't just pockets of air. They are the most secure hard drives in the known universe, recording the chemical signature of the atmosphere with a precision that no man-made device can currently match over such a vast timescale. To understand why these bubbles are so special, we have to look at the process of their creation. It begins with a single snowflake. As snow falls in the coldest regions of the planet, it doesn't melt. Instead, it accumulates in layers. Because snow is naturally fluffy, it traps about 90% of its volume as air. As the years turn into centuries, the weight of the new snow begins to crush the layers beneath it. This transition phase is known as firn. In the firn layer, the air can still circulate between the grains of ice, but as the pressure increases, the pathways between the snow crystals begin to close. Eventually, at a depth of about 50 to 100 meters, the ice becomes so dense that the air is completely sealed off from the outside world. The right process of this biological hard drive is now complete. Once sealed, these bubbles become a closed system. Unlike a digital hard drive, which suffers from magnetic bit rot, or a paper book, which decays and yellows, the air inside a glacial bubble is held in a state of suspended animation. At temperatures far below freezing, chemical reactions slow to a near halt. There is no oxygenation, no microbial degradation, and no leakage. Each bubble is a perfectly preserved sample of the atmosphere exactly as it was the moment the ice sealed shut. This is why scientists refer to them as the only direct record of the past. While we can use tree rings or fossils to infer what the climate was like, glacial bubbles allow us to actually reach back and breathe the air from 800,000 years ago. But what kind of data is stored in this cryogenic cipher? It's far more than just oxygen levels. These bubbles hold a complex dataset including carbon dioxide concentrations, methane, nitrous oxide, and even the isotopic signature of the air. By analyzing the isotopes of oxygen and hydrogen in the ice itself, scientists can determine the exact temperature of the planet at the time the bubble was formed. Furthermore, the ice surrounding the bubbles traps volcanic ash, desert dust, and even radioactive isotopes from past cosmic events. It is a multi-track recording of Earth's biological, geological, and even astronomical history. Decoding this cipher requires incredible engineering. Scientists use massive drills to extract ice cores that are kilometers long. These cores are then transported in specialized refrigerated units to laboratories where they are kept at -50 degrees Celsius. To read the data, researchers place small samples of the ice in vacuum-sealed chambers. They use a process called needle crushing, or grating, to break the ice without contaminating the air inside. Once the air is released, it is analyzed using mass spectrometry and gas chromatography. This allows us to see how the Earth's climate has cycled through ice ages and warm periods with a resolution that is almost daily in some high accumulation areas. The security of this hard drive is entirely dependent on its environment. As long as the ice remains frozen, the data is immutable. However, we are currently facing a massive data corruption event. As global temperatures rise and glaciers melt, the archives are literally evaporating. When a glacier melts, the air bubbles are released, and the record of that specific era is lost forever. It's like a fire in a library that contains the only copies of the world's history books. This is why there is a frantic race among glaciologists to collect heritage ice from disappearing glaciers, storing them in a global vault in Antarctica to ensure future generations can still access the data. In a world where digital formats become obsolete every decade, the glacial air bubble stands as a testament to the power of physical, elemental storage. It requires no electricity to maintain, it has a shelf life of millions of years under the right conditions, and it records the truth of our world without bias or error. The cryogenic cipher is a reminder that the most profound technologies aren't always the ones we build. Sometimes, they are the ones we simply have to learn how to read. For more incredible facts like this, don't forget to subscribe and turn on notifications.